At this point, there's one more thing that we want to do here, and that's we're going to add a competitor. So a competitor can be either like another shark, or it could be maybe smarter enemies or smarter fish, but something to add another layer of complexity to your game. So to help give you an idea of exactly what I mean, I'm going to create one with you here. So I'm going to make a new subclass, and what I've done is I've just made a, where's my shark? Oh, I'll have to go and get my shark, just a second here. Let's try that again. There's my computer shark. So computer shark. And all I did is in Photoshop I just inverted the colors, so it's hard to see the image now that it's small, but anyways, we'll see it again in a second. So what I'm going to do here is add a, I guess we'll call it a smart shark. I'm going to be working with lists again, so we can import it right at the beginning. But basically this is going to be, I guess we'll call it a smart shark, but it's more of just an autonomous agent. And the way the agent's going to work is it's going to look for the nearest fish, and then it's going to go and eat that fish. So I'm going to show you how to program that behavior, and I'll make a method here that's maybe useful to you in your code too. One, to find the nearest object. So we want to be able to build a generic function, one that can return any type of object to us. So I'm going to use the object class. Remember, everything in Java is an object. It's inherited. This is the one top class that everybody inherits from automatically, whether you declare it or not. This is me declaring it explicitly as an actor, but whether I did that or not, even an actor is going to inherit from this object class. Now, I'll call this getNearest, and I need a class. So this is the kind of method where you'll just declare, like when you use getIntersectingObjects. You'll be able to see the advantages when we implement this method in a minute here, but let's go over how to build it. Okay, so the first thing I'm going to want is to get the world out of this. I'm going to use it quite a bit, so I'll store it in a variable. Now that I have the world, what I'd like to do is get the objects of this type here, this class C. So I'll call this a list, and these will be my prey, equals world.getObjects, and I just give it C. That way it will take all of the objects of type C and put them in a list. Now what I'm going to do is I'm going to figure out the closest distance, and the way to do it is to first get the x coordinates of this computer shark. So let's go like that and say x is get x and y is get y, because I'm going to need those coordinates to figure out how far away the other objects are. I'm also going to need to know how big this list is when I traverse it. So I'll ask for that prey's size, and it'll tell me how many objects I have in there. Now, to know if I'm closest, I have to keep track of what the closest distance is. I also have to keep track of who the closest object was. So this is something that comes with a bit of experience of knowing ahead of time what you need to program in. But this is what I mean. I'm going to have a double, which is the minimum. And there's a constant in the double class called max value. And I'm going to use that. That way, the first time I call this distance, it's going to be beaten because it's the biggest possible one. And you'll see in my loop why that makes sense. The other thing I need is I need an object called nearest, and I'm going to start it at null because I don't know what's closest. There may not in fact even be an object if there's no members of this class present. So I'm going to initialize it to null, and then basically the end of my method is going to be return the nearest. But I need a loop now that's going to calculate how far each object is and which one then is closest from it. So I'm going to use another for loop here. And I'm going to do it through the size of that loop. And the first thing I need to do is get that object off of the list. So I'll go actor, A is an actor, and I have to cast this out of my list. Sorry, I've called it prey. And the reason I'm casting it is right now it's just an object. I don't know exactly what kind of class it is, but I do know that whatever class it is, it's an actor. It's one of the characters in my Greenfoot game. So down here what I'm going to do with it now is calculate the distance. And I'll do that with the Pythagorean theorem, distance between 2 points. So it's going to be the distance between x and the actor's x squared plus the y and the actor's y squared. So that's my Pythagorean theorem for the distance between the shark and the possible prey that I'm at right now. What I'm going to say is if that distance is smaller than the minimum, then that means I've got a new closest object. So in here I have to update all the conditions in my loop. So the minimum is now this distance I just calculated, and the nearest is this actor A. So what's happened is I initialized this to be the maximum value because, well, you'd hope that first time you calculate the distance, it's going to be smaller than the largest possible value that Java can store. That way, if there's only one item, it's going to win here, it's going to update to be the minimum distance and tell me that the nearest object is that actor I just found. So it basically goes through the loop, and anytime you're beating the minimum, you keep updating it, so you're keeping track of who the smallest object is and how far away it is. You do have to keep track of both, because you need to update the smallest distance so that you know who the new number to beat is, and you have to keep track of who made it so that you know what object it was you're referring to. That way when I get to this part of the loop, I can return that nearest object here. Okay, so now we're on our way. We can get a nearest object that we want, and in our case it's going to be the fish. So I'll sort of map out to you the way the act method is going to work here, and I'll say fish f equals, and I have to cast it because remember it's returning an object. I have to tell Java what kind of object this is, so get nearest, and in here I'm going to say fish.class. And again, that's a nice generic way of getting your using your method, because now I can do it for a fish, I could do it for a torpedo, I could find just about anything that's closest to me as the shark and know you know, what's of maybe highest concern. So now that I have the fish, it could be null, and that's a problem. So basically what I want to do here is make sure, be careful, so if the fish is not equal to null, right, there's nothing to eat. So we can deal with that later. Right now I'm just going to let the shark move if there's something to go and eat. So now that it knows where it is, maybe I'll make here, I'll call this speed, and that's going to be how fast it moves towards that fish. So what it'll look like then is I'll say, now that we've found it, I'll say turn towards, and I'll get the fish is X, that's my target, and the fish is Y, and then I will move by that amount. So if you made this number larger, then it would be, the shark would be moving faster. So I think 2 is pretty reasonable to see when the game runs, but I'll turn towards the shark and move. Now of course I need to see if it's time to eat the fish, so I'm going to just make a little template here and we'll fill in these codes here. So if I found a fish, then I'll eat the fish. So that means I need 2 new methods, and I'll put them down here. I need a public boolean found fish, and just return true or false if I'm intersecting with a fish right now. So I'll use a list of type fish, and call this prey again, I guess. Get intersecting objects, and fish is the class that I'm looking for. And all I want to know is the size of this list is greater than 0. There's something to eat if this was more than, as long as there was more than nothing there, there's something to eat. And then the eatFish method is just going to be a void. What it's going to do is it's going to get those fish, and I'm going to be a little more robust than we have been. I'm going to go through and actually eat each of those fish. So I'll loop through all of them. And for each one of them, I'll say fish f, and I'll cast it. Actually, sorry, I don't need to cast it here. The reason I don't need to cast it is I've already declared to Java what's in there. So I'll say prey.get at index n, and then I can say I want to remove this from the world. So I guess it'd be good code here to declare the world, since I'm going to keep reusing it. and I'll say w.remove object f. You could just take this method and copy it from here and then overwrite it there, but then that means every time this loop runs it's going to call that method again, and sort of unnecessary to do that because I can just store it and call the method once. A little more efficient anyways. So this will go through and eat the fish the way we have done it there. So I suppose at this point we can go and take a look at what our shark looks like. We'll compile the project, and I'll put one in the world so that we can run it and you can see what my competitor is doing. It's finding the closest fish to eat, and it is taking all of my fish away from me.